All right, the last one we're going to do for tonight, seeing as it's almost 11:15, and I've been going all day, is, oops, that was my knuckle there. Let me erase that. 4.33, which is a sort of a modified Atwood. You have a mass here. I think this one is A, with a massless string, or thin cord as they call it, connected to B over the top. And it says MA is 13 kilograms, MB is 8, oops, no, not 8, and mine it's 6 kilograms, let's do this better, 6 kilograms, that's cleaner. And it says it's a smooth horizontal surface, so this right here, mu is 0, it's frictionless, which is going to make this easier. So we're going to apply F net equals MA because we're interested in solving for A initially. So if we draw a free body diagram, you get FG over here, which is MBG, and you have tension, and you have tension this way, and you have nothing in this direction because there's no friction. So I'm going to pick down as positive because that's the direction that is going to move here. So I'm sort of looking at it as who wins, and B wins, obviously. A is not going to win. So if I do this for mass B, F net is going to be MB times G minus the tension equals MB times A. Whoops, lowercase a. And that A is not P or A subscript because the acceleration of the two blocks is the same. And for block A, I'm going to say, well, tension is to the right is going to cause MA to accelerate to the right. Simple math trick, we'll add, the tensions go away, and you get MBG equals MA plus MB both times A. Divide that over, and you get A is equal to MBG divided by MA plus MB. I think if you do the math, you get about 3.1 meters per second squared. All right, part B of this is not too difficult. It's a kinematics problem. They say MA is 1 point, at least in my question, 2.5 meters from the edge of the table. How long does it take if it's allowed to move freely? So you want to know T to travel that far. So this is just a kinematics question. You have A is, I think we said 3.1 meters per second squared. V initial is 0, starting from rest. Delta X is equal to 1.25 meters, and you want to know T. Hopefully at this point kinematics seems real easy, and you probably jumped right to delta X equals V naught T plus 1/2 AT squared. You plug in that, you plug in that, which makes that go away. Plug in that there, and solving for T, you get something like, I don't know, 0.9 seconds, give or take a thousandth of a second maybe. So that was part B. And the last question is asking if MB were 1 kilogram, how large must MA be such that the acceleration of the system is kept at G over 100 is what A is equal to. Well, if I could go back a few slides, I would see that the equation that I got for A was equal to, what was it, MB times G divided by MA plus MB. So we want A to be G over 100. MB is 1. So you have to figure out what MA has to be for this equation to work. So, whoops, MB we said, was 1 kilogram. So 1G, that's good on the top, so 100 has to equal MA plus 1 kilogram. So it looks like MA. Pretty simple. 99 kilograms. I know I keep saying this stuff's simple, but the more you practice, the easier it gets, and it's not so daunting because you start to have this physics sense. Some of you will get there in a few days. Some of you it may take, well, you'll get there. We don't care how long it takes as long as you get there. All right, that's it.